to friends. In this video, I'm going to solve a problem on adapt to linear network. It's nothing but ADALINE network. Okay. Here is a question. Given four input vectors and their target values, uh, and given bipolar inputs. Okay. So first, what we need to find is initial weights. Here, no initial weights were given. So we have to assume initial weights 0.1. So W1 is equal to 0.1. W2 is equal to 0.1. And bias is equal to 0.1. And learning rate is also not given. So by default, we are going to use 0.1. Now we have to calculate the net input value for each input. So for first input, y net input is equal to, the formula is bias value plus weight 1 into x1 plus weight 2 into x2. So the bias value is 0.1 plus W1 is 0.1 into x1 is 1 plus W2 0.1 into x2 1. So if we simplify this, we will be getting 0.3. And the next step we need to find is we have to compute target minus or calculated net input value. So target value is 1. So 1 minus 0.3. We will be getting 0.7. And now we have to find new weights to use for next input. So to calculate the new weights, the formula is W of u is equal to W of old plus alpha into t minus y into x. So now let's find W1, new W1, the old W1 is 0.1 plus alpha 0.1 into t minus y, we got 0.7 and x1 is 1. So for this we will get 0.07, so 0.17. Now find new W2. Old W2 is 0.1 plus and alpha 0.1 into t minus y 0.7 into and x2 is 1, so 0.17. And new bias value, old bias value is 0.1 plus, and for bias B of old plus t minus y into x, sorry, t minus y into alpha. Okay, I will write clearly. So new bias value is old bias value plus t minus into alpha. So old bias value is 0.1 plus t minus 1 0.7 into 0.1. So this we will be getting 0.17. And the next step what we calculate is we have to calculate error. we have error E is equal to t minus yn whole square. So t minus yn is 0.7. So 0.7 is 0.49. So our final weights and bias and error value are, so W1 is equal to W2 is equal to the bias not W3. Bias is equal to 0.17 and E is equal to 0.49. Now these updated weights are used to calculate the second input. So if we remember, for second input, x1 is equal to 1, x2 is equal to -1, and target is equal to 1. And the weights are 0.17, 0.17, 0.17, W1, W2, and bias. So now calculate that input value. Yn is equal to bias 0.17 plus x1 into W1 0.17 plus x2 -1 into W2 0.17. So these two will get cancelled. We will be getting 0.17 as Yin value. Next step is what? We have to subtract our calculated net input from our target value, right? So t minus Yin is equal to 1 minus 0.17, that is 0.83. And then we have to calculate our new weights. So new W1 is old W1 0.17 plus x1 1 into t minus Yin 0.83 into alpha 0.1. So for this we will be getting 0.253, I guess. Let me calculate. 0.17 plus 0.083 and 0.253. And new W2 0.17 plus W2 is -1, right? -1 into 0.83 into 0.1. So for this we will be getting 0.17 minus 0.083. So this is 0.087. Now new bias value. Old bias is 0.17 plus t minus Yin 0.83 into alpha 0.1. So this we will be getting 0.253. Now we have to calculate error value, that is t minus Yin whole square. So 0.83 square. So we will be getting 0.6889. So our new weights and error value are W1 is 0.253, W2 0.087, bias value 0.253, and E is equal to 0.6889. Now with this new updated weights we will be performing for a third input. Input 3, if you remember, x1 is equal to -1, x2 is equal to 1 and target value is equal to 1. So now our updated weights are 0.253, 0.087, 0.253. Now calculate net input. Bias value 0.253 plus W1 0.253 into x1 minus 1 plus W2 0.087 into 1. So this you will be getting 0.087. Now T minus Y, that is 1 minus 0.087. So 0.913. And now new weights. New W1 is equal to old weight is 0.253 plus alpha is 0.1, T minus Y in 0.913 to x1 minus 1. So this you will be getting 0.253 minus 0.0913. So 0.1617. Next, new W2 is equal to old W2 0.087 plus alpha 0.1 into 0.913 into x2 is 1. So 0.087 plus 0.0913. So this is 0.1783. Now new bias value 0.253 plus T minus Y in 0.913 into alpha 0.1. So this is 0.253 plus 0.0913. So you will be getting 0.3443. And error value. So T minus Y in square 0.913 square, that is 0.834. Okay, so our new weights 0.1617, 0.1783, 0.3443, and error is equal to 0.834. Similarly, do for fourth input. Input 4, x1 is equal to minus 1, x2 is equal to minus 1, and target is equal to minus 1. And the weights are 0.1617 and 0.1783 and 0.3443. Fine. Now find my input. So bias value 0.3443. This is in the order of W1, W2 and bias. So kindly ensure that you are substituting correct values in the formula. So bias value plus W1 0.1617 into x1 plus W2 0.913 1783 into x2. So this you will be getting 0.3443 minus 0.1617 minus 0.1783. So 0.0043 and t minus y in 1 minus 0.0043, that is, so target is also minus 1. So minus 1.0043. Okay. Now find new weights. Mu W1 is equal to whole W1 0.1617 plus alpha 0.1 into t minus y in minus 1.0043 into x1 minus 1. So this we will be getting 0.1617 plus 0.10043. So 0.262 and new W2 whole W2 0.1783 plus 0.1 into minus 0043 into our x2 is minus 1. So this will become 0.1783 plus 0.10043. So 0.278. And our new bias value, is old bias value 0.3443 and t minus y minus 10043 into alpha 0.1. So 0.3443 minus 0.10043, that is 0.244. Okay, and finally we have to calculate error value, that is t minus y in square. So minus 1.0043 square, that is 1.0086. Fine. So with this we completed one epoch. So now after completion of an epoch, what we have to do is we have to calculate the total of the errors which we obtain in each input. So for first input, our error is, right, see for input 1 we got 0.49. So our total error 0.49 plus, and for input 2 we got 0.689. For input 3 we got 0.833, and for input 4 we got 1.0086. So now we have to add this and we will be getting 3.02 is our error in our first epoch. Similarly, we have to perform next epochs, further epochs, and calculate the total error like this. And the stopping condition for this ADALINE network is initially you have to assume an error like like the initial error be I am assuming like 0.5. So we will be performing epochs and calculating this error, the final, right? If we got the error value close to the initial assumed error value, then at that particular moment, we can stop performing this ADALINE network. Okay. So in my first epoch, I got 3.02. If I perform further epochs, it will get reduced. So uh, if at all I got some 0.49 or 0.45 at some particular epoch, so at that time I will be stopping performing this ADALINE network. This is the stopping condition for ADALINE network. Else, if you can do for 3 epochs and can stop. Okay. But you should not assume, if I assume error rate in if I assume error rate, bigger error rate at the beginning itself, like if I assume 3, here itself I got 3.02, and in my first epoch itself, I will be concluding my ADALINE network. But having error rate as 3 is not at all good. So definitely it should be less than 1. So try to assume error rate is less than 1 and try to perform epochs as as many as you can. So this is about ADALINE network. Thank you.